All right, I'll go ahead and get started as people crawl on in. It's very introductory stuff in the beginning anyway. So this, let's say, session that we have is really on like practical workflow tips and tricks for Git in Python. So it's not going to teach you how to use Python. It's assuming you know Python, but it's how to have your workflow kind of smooth so that when you're working on your deep learning project or when you're trying to use someone else's deep learning project, you can have a clear procedure. Because as you saw in the first session, there can be so many different parameters, settings that you have to keep track of, and it can feel overwhelming at sometimes. And the goal of some of the things that we'll show here is, okay, how can you set up your workflow so that you can see what one hyperparameter, how that changes and gets specific outputs, or how another parameter gets another output. So, and then these tools will also be really, I guess, useful not only if you're working in deep learning, but any sorts of engineering project that involves coding. So hopefully you find it useful in those contexts. So here we've merged two workshops that we usually do with LauzHack into one. So hopefully it's not too dense, but we'll see. I'll try to make it interactive so that you can ask your questions in between. So as Peter mentioned before, so I'm part of the LauzHack team since the beginning, since 2016. So that's been too long, but hopefully next year I'm out of here. Boom. Peter will take over some stuff, other people's, and Parsa, who you'll see on Wednesday. So like Atli, I'm doing a PhD in computer science here at EPFL. And actually, between my master's and the PhD, I worked for a couple of years at a startup called Snips, which was then bought by a bigger company called Sonos, which they make nice speakers. And so some of these tips I got through my research experience, but also working in industry. So first part of today, we're going to look at Git and GitHub, some very basic intro stuff. So who here has used Git and GitHub before? Okay, so I think we can go quickly through a lot of this stuff. So that's the first part, but then through it, I'm also going to expose you to an IDE, which I personally use a lot, called Visual Studio Code. Who uses VS Code? Okay, so then we can also go quickly through a lot of that too. And then we'll just talk about some nice features in GitHub, like, okay, if you see a project that you find interesting, how do you contribute to it? Or how do you collaborate with other people? Some nice features on GitHub. On the Python side of things, probably also stuff you're familiar with, so we can go quickly through that. Creating virtual environments, some tips for using VS Code. This will probably be new to you. So this is a more interesting part called Hydra, which is sort of a way to, let's say, it does many things actually. So it gives you a command line interface for your code and also spits out outputs for your code. But we'll get to that in a bit. So it helps you manage your different experiments, which will be super useful for machine learning experiments. And then we'll talk about some libraries, not PyTorch related, which can help you for GPU. Because I think one thing we didn't mention with PyTorch is you can use it just to help to do compute on GPU as well too. And so we'll see other libraries or other like scripting tricks you can use to explore things and make stuff quicker in Python.
Preprocess instead of.
What's that?
You can use them to improve preprocess instead of your like job leak, and they use.
Yeah, these are different techniques you can parallelize over multiple CPUs or GPU, which you could also do with PyTorch. And then I'll talk also on like how could you package your code, like how do you make it nice on a GitHub repo? How can other people pip install your code? So you probably used pip before. And then this is all within a documentation or toolkit, which I put together called PyDevTips, which just has different ways you can do different stuff when you're working in Python. So that'll be like the second part. And so you can follow along in the slides if you think I'm going too fast or too slow. That's the QR code. And then they should also is that materials folder public to them where you put the stuff?
The links are on GitHub, and I will add your link.
I put a copy of the slides already in the. Okay. All right. And then you're paying attention on Zoom if there's any questions or stuff. Okay, cool. All right, so let's go through this. Okay, most of you know GitHub. So just to remind all of us the difference. So Git is, let's say, a protocol, or what one would call a version control system. It's okay keeping track of when different changes are made and who's made those different changes. And the two terms I'll be using a lot are you can be using it remotely. So when we use it on a server like GitHub, or we're going to be using it locally for example, on my local laptop, or I may also refer to, let's say, a remote server that I use as a local place, because that's where I'm going to be working on a remote setup, and then I'm going to be pushing or sending changes to GitHub. So that's the protocol. And GitHub is just something that tries to have a nice interface around this protocol. And one analogy I give for non-programmers, let's say my wife or some other friends, I would say, okay, GitHub is like the Facebook for developers. I mean, it's a way we can share, exchange our code, like each other's code. You know, I don't think you can do, maybe you can do posts on GitHub. I don't know, but I don't see many people doing it. So it's just one interface on that helps you use this Git protocol. And why would you want to use version control? So it gives you a nice way to keep track of what changes have happened. And this is especially useful, for example, if you're exploring different, let's say, ideas that you may have, let's say in a machine learning project where maybe you made some change, you realize there's a bad change. Okay, I want to go back and reverse that change. Or if you want to explore multiple things in parallel. So that's like this visualization here. Let's say one person's going to work on another feature, someone else is going to work on another feature, but you're going to work on some core code which may break each other's individual experiments. So you would do this thing called branching away from this core code, try out your ideas, and then when it works, you try to put it back together. But then you can get into some conflicts, which we'll look into a bit. How many of you had merge conflicts and don't like them? Well, we'll try to simulate a small example and show you, okay, how something like VS Code, which is another graphical tool, will help us with that, but also how GitHub helps to dealing with these, okay, merging of code. So, but version control, I guess you can probably see how it's useful because, okay, one thing that probably most of us has done, who's sent code files over email or WhatsApp to each other. Yeah, that's not a very good way to keep track of what happened. Maybe you try to write a nice long README within your WhatsApp messages, but then, yeah, that's the best you can do. Here you can really have, okay, a nice way to go back to things and actually, okay, kind of time-stamped and kind of person-stamped idea of, okay, how code has changed over time. And instead of, let's say, manually sending files, what Git is going to do is just going to keep track of the changes, not just the whole set of files. So if you have like hundreds of source code files, that is so much nicer to just see, okay, what couple lines changed rather than having to email all of your source code to your friend or to your collaborators. So I mentioned GitHub, but there's other alternatives. GitHub, I guess it's one of the pros of being early to the market is that and also having a nice mascot, which is their Octocats, is that they've gotten way more popular, and then Microsoft bought them. But there's other alternatives, which you'll definitely hear at EPFL, who maybe they want to use more open source versions. So, or in companies, sometimes they would use something like Bitbucket, which comes with all sorts of other industrial, some other tools. But we'll look at GitHub mainly today. And it's quite a popular one in the machine learning community to share your source code or to also find what other people have done to not have to reinvent the wheel. So yeah, I mentioned some of these pros and cons. Open source, GitHub has some really nice features when it comes to these things. Code review, continuous integration, which is like, okay, when you make changes to your code and you want to test the code to see if it still meets some certain tests, and project planning. And yeah, so those may be different reasons why or not GitHub. So setup, I guess everyone has a GitHub account, but if you don't, go ahead and make one. And then you also want to make sure you have Git installed on your laptop. We're going to be trying some stuff on the computer just to get familiar with VS Code and other stuff. So if you're on the slides, you can press on that link. And essentially, if you open a terminal on your laptop, you can just type Git and you'll see if you have it installed or not. Any questions from there? Okay. So creating a repo. So I'm going to just show you some tips that I do when I create a repo from GitHub, which even if I'm not going to make it open source, it's still a nice way to start a project because they have a lot of boilerplate files, which would be useful in your personal project. And then you can always make the repo private so that, okay, it's just only for yourself, this code base. So when you go to GitHub, you would go to this is what you see when you go to github.com. You have the repos you work on, some news feed here, some other stuff. There's this green button which you can press on to create a new repo. You can give a name to it. So I just took like a dummy name that it gave for some inspiration since I had none at that moment. And as I was mentioning, I keep this private because for now I'm just going to be working on it by myself. You can also do this for your school projects if you just want to start by yourself because you don't want to be publicly shamed of your dirty code that you have out there. So you can start private. And so these next bits are what I like that GitHub provides, so that you can have like a graphical way to initialize these files. And one of them is a README, which is something you pretty much always want to have in some packaged code base. And as the name in bold is trying to do, is trying to catch your attention to essentially read it. And what GitHub does is that they use this page or this document as like the home page when someone goes to your project. So usually I start with a README. One little side note, so I'll mention about documentation later on. A lot of documentation, but there's some now that was based on Markdown. So what GitHub will do is that it'll start a readme.md file, which is for Markdown, but some documentation frameworks use RST. So maybe you want to not click this if you know you may want to build documentation around it, because RST is a common framework for I think it's restructured text, something like this, for building documentation with Python. So there's all sorts of good templates. But that's just a side note, not very important for now. Another very useful feature when you do starting a project from GitHub is that they have this templates for .gitignore files. So who knows what a .gitignore file is? What is it? Yeah, exactly. So it's a file which is going to list all the different types of files that you don't want to share in this code base, because maybe they're compiled files, maybe they're data sets, especially if you're working in machine learning. So GitHub is not going to know those specific data set stuff, but it has templates of, okay, what are typical files in Python which you're never going to want to push? So like compiled files, or say IPython notebook checkpoints and stuff like this. So it's good to pick, for example, Python here, if we're going to be working in Python in our case, and then you can manually edit this file to then put the paths to your data sets, to model weights or whatnot, when you're then changing it locally. So that's a good thing to add. Another thing which I strongly recommend is to add a license, because if you don't have a license, people are not going to know how they can use your code. And especially if you're in industry, they're actually not going to let you use software that probably doesn't have a license. So it's good to have a license, so that, okay, for some reason, if you never touch their project again, someone can still use it, and then maybe you get a star or something on GitHub. So a common one in academia is MIT, which is like, okay, you can use it as you want. But if you really want to know some more knowledge on which is the best license, so I think they put the link. I guess if you click on that learn more, it'll take you to this website to choose a license, which then helps you navigate, okay, all these different choices. Okay, I want it to be simple and permissive, which means, okay, MIT would be like the very simplest there, where it's just saying, okay, you can do whatever you want. But if you want people to open source the code that they use with your code, you would go something more this direction. Like, I want people to share the improvements that they make. So that's this GPL stuff usually. Okay, so once you figure out all, let's say, these different parameters for your repo, and all of them can be changed later. So that's why even if you start in private, just initialize it with something, so you have something to start with, and you can always change it later. Even the visibility of them, you can change later. And then you'd go ahead and press the create repo. And then, yeah, you'll get to a page like this, and we'll see a bit more about this in a bit, all these different tabs, what you can do with them. But the first part, which is interesting, is, okay, how do we actually now code and work with this? So they try to make it visually appealing, and this green code button. So there you would see these different options for what they call cloning the code. So cloning is just another way of saying, okay, to download or kind of copy that code. So there's multiple ways to do the same thing, which is often the case in open source. So either you can clone it via the terminal. So these are the different commands that they give you through what's called GitHub Desktop, which is a software that GitHub has prepared to kind of manage repos. And then we'll also see another way through VS Code. So on the easier way, which is what I would recommend, because it's just better for faster workflow, but we'll also see the terminal version if you don't have the graphical option, is, okay, downloading GitHub Desktop. This only works with Windows or Mac OS though. Somewhere you can find some versions for Linux. When I first did this tutorial, they had it, then it got away, so I had to update these slides for that. So for that, when you go on that code, you just press this open with GitHub Desktop, and then what it would do, there would be a pop-up that's saying, okay, choose the application, and then it'll open the repo there. So I won't go deeper into there, because the one I would really more strongly recommend is to use source control or GitHub or cloning repos through an IDE. So IDE stands for Interactive Development Environments. So like VS Code, as I mentioned. So if you don't have it, you can go ahead, download it for your OS. I'd recommend using this. And okay, just to kind of give the other options of IDEs that are out there. So there's VS Code, which we'll focus on in this tutorial. There's also PyCharm, which is quite popular, Replit, which is a browser-based, Spider, many. VS Code, I think, is probably more. Do you think it's one of the most popular ones? I don't know.
VS Code, PyCharm, and one is it's not Spider, it's something else.
Okay.
Sublime.
Sublime, that's like more of a text editor, but I don't know if it has all the
Visual Studio Code and Vim plus extensions.
Vim plus extensions. Okay.
Yeah.
For the brave. But we'll look at VS Code and reasons not to use Sublime or Vim. Okay, you can do syntax highlighting with Vim, I guess, and also Sublime and extensions. But then there's all sorts of other stuff. Let's say if you have hundreds of files, there's all sorts of stuff that it does in terms of what's called indexing your code. So you can click between files, you'll know where it was declared. You can then change the name of it elsewhere. And what we'll see in a bit is you have this integrated Git support, an integrated debugger, autocomplete plugins like for Copilot to do kind of autocomplete on steroids. So we'll see a bunch of that in a bit. So the whole point of this workshop is not to make your life complicated. So one way is just to get an IDE, so something like Visual Studio. Okay, so then let's see how you would go about cloning or downloading this repository from Git. So when you open up VS Code fresh, you'll see these different options. Either you can do a new file, open a project, but we're going to click this option, as it says, to clone a Git repository. So there's two options here. Either you can copy and paste your URL, as I've shown there. So this is where my repo that I just created is located, or you can press this clone from GitHub. And when you press clone from GitHub, essentially it's indexed all of the public repositories, maybe even your own private ones, in this search bar. So essentially, all I would have to search for is eBasm upgraded potato. So as I said here, username and repo name, and that's what you use to search for that repo. And then it's going to ask you, where do you want to store that repo? So then you navigate through your file manager, you select that place as destination, and okay, it'll ask you at the end, after it's downloaded all the files to that location, I'll ask if you want to open it, and we open it. And okay, I don't have the slide for that, but then you'll have all the code there within VS Code. So let's see if I think I opened it here. Here. So I renamed it to upgrade potato v1. You'll see in a bit, but then you'll see all the files here. So we have the git ignore, which we initialized on GitHub, the license file, which we initialized MIT, a simple Python script, which we'll look at in a bit, and simple README. All right. Any questions on this?
You could get started if you would make it fun.
Huh?
I think you could get started if you would make it fun.
Yeah. This one is not public, but yeah. I have another public one which you can give me some stars on. We'll come to that in a bit. To what? Which the PyDev tips or okay. We'll get to that in a bit because we're gonna use your laptops and then work with another code base in a bit. Okay. So we open the repo. Okay, so that's the easier way. Let's say the more intermediate way is I'm just going to show you quickly what would be the commands if you were on the command line. And this is useful, for example, if you're not able to have VS Code on, let's say you're working on a Raspberry Pi or something, or you don't have much internet and you just want to go on the keep it simple and low overhead. So I'll just show you the commands here, and essentially these are the commands which VS Code is kind of doing in the backend, and it will also expose us to some differentiations between HTTPS and SSH. That's useful. So if you want to do the command line version, you would have to open a terminal and you would copy either the HTTPS or the SSH. It will just change sort of the prefix that's here. And what these two are, there's essentially two different protocols that you can exchange information over a network. So I'm not sure if the HTTPS is still supported through GitHub, but they're trying to gently push people. But It's supported still? Okay. But it's better to go with the SSH option for the more practical reasons. You don't have to enter your password each time. Yeah.
Says that if you are cloning your repo from some public server like Colab or Kaggle, you won't be able to do SSH. You need to do HTTPS.
If you're cloning a public repo,
You open Colab and you
Yeah.
want to clone repo to Colab, you can clone it only using HTTPS.
yeah, because I guess there you can't exchange public and private keys. Is that why? Yeah, so that's the reason there. But if you're ever going to want to make code changes, it's best to use the SSH option, because then you're gonna have to enter your password each time whenever you want to push, and it may not give you the rights to push. But essentially what SSH is doing is you're going to create two keys. One is a private key, which is going to be on your local computer or your local server, and another public key, which you share to GitHub. So that whenever you run these commands, it doesn't need to ask you your password, because it's going to compare these two keys to make sure they sort of match in a certain language. So if you were to do the cloning of a repo, I would recommend SSH, unless as you were in a collab, as Peter was mentioning, where you'd probably be restricted to only using HTTP. And working with SSH may not be the most intuitive to some people, so I just tried to put some of the steps here. And this is useful if you're ever needing to SSH into a machine in general, like to a Raspberry Pi or to, let's say, a remote server. You'd probably go through this setup at one point, and it's good to know kind of the steps on how you go about it. And the general ideas of how you exchange these SSH keys is you create this public private key locally in your computer. So who's done this before? Creating SSH keys? Okay, so I'll show it for the other half. So you create this public and private key. You share your public key to the machine or entity you want to exchange with, and then you can do your interactions. So in this case, the cloning. And so these next few slides, I've given kind of the instructions of how you would create those key pairs. And GitHub has some nice documentation on that. So if you go to this link, if you're at the slides, essentially, you just make sure you have the right OS, and it gives you the commands at this page in order to generate those pairs. This would then be the command, depending on the OS, to copy your public key. So it ends in .pub. Don't copy the other one. Copy the one with .pub, which is for public. And then those contents, you would then have to share it to GitHub by going to settings, SSH GPG keys, new SSH key, and you paste the contents into here, and then you can name it like my personal computer, my work computer, and then that's how you would add your key to GitHub. Different, let's say, if you're working with a Raspberry Pi, would have different ways of storing these keys, but this is how you do it with GitHub. And then you can go and you can do SSH cloning freely and without any password. Or if you wanted to connect to a server or a Raspberry Pi, using SSH would allow you to connect to it without having to use your password each time, which is more convenient than HTTPS or other versions. Any questions on that? I think, okay, for everything related to this bootcamp, you'd probably do stuff through VS Code, just cloning through VS Code. But it's just good to know the command line options, which we'll come back to command line options in a bit for when you want to do this type of stuff. Any questions on that? Okay. Okay, so how do we now push changes? So that's the Git terminology for essentially uploading or kind of sharing these changes to a remote repository. So the general workflow is you'll make some edits to your files. You're going to add new, changed, or deleted files that you want to eventually push. You'll commit them, so kind of stage them to be able to then upload them. So this last step to push, so you can push one commit or multiple commits, but each of these commits ideally describes a unique change. So that's the workflow more or less. So let's look at that more concretely. So I'm going to give you a little exercise here. So here we're in my upgraded potato. This is what it looks like before. It looked different when I showed you before because I had done some changes. So this is before. Hello world, my name is Eric, how are you? This is after. How many changes are there? Peter, don't say anything.
File and also already did.
So wait,
New files, new files.
wait, okay. Give me what's the first one you say? New file. So this thing. Second one.
See on the first row, there is a dash, how you call it.
Where?
It's modified. Like on the first line, I don't know how you call the stroke, but like.
This thing?
Next one, number one.
Ah, this is something that this is just saying it's modified. But what's been modified here? Yeah, so there's a comma here now. So that's that. The reason why it has this dash thing is, and why you'll see that it turned into yellow and there's this M is because it's modified. And the reason why it was modified was this comma. Anything else changed? Yeah, that's the tricky one. You don't see it, right? You have to really pay attention. The README is gone, and this is where using an IDE is useful, because actually you could have seen the number of changes at one point. Where do you see it? You see it here on the 3, and essentially these are different tabs on your IDE. Where this is your file explorer, where you can see the individual files. And as we saw, I added a file, so that's going to be in green. I modified a file, which is going to be in yellow. But since I deleted the file, I don't see it anymore in the Explorer. So I could have lost track of the fact that I deleted this file if I'm not using an IDE like this. So that's what's nice. So if we go to there, we'll see, okay, what actually changed. And when I go to this source control tab of the IDE, then I can see all the changes that have taken place. I had the new file, which is in green, modified in yellow, and in red, and also kind of crossed out, it's showing me what file that I deleted. So here we see one great use or benefit of using an IDE when so this is a very simple example, but imagine if you had hundreds of files where, okay, you quickly change stuff, blah, 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 and then yeah, you can lose track of things. So this is very useful. And then also it's pointing out where exactly I changed things in that one line of code, instead of trying to remember, okay, where did I change something? And really having to do this exactly before and after thing, you can, okay, really open this and it shows you clearly the before and after. So essentially there's actually another thing I changed. I removed the capitalization on the W, lowercase, and then I added the comma. So those are the 2 changes that we see, or 4 changes actually, but in 3 files. So in order to see the difference, you'd have to just click on one of those files and it shows you what's this working tree version, where it shows, it'll do in red the line that was kind of being deleted, in green the line that's being added, but then it also highlights the actual changes in that line.
Just on files, right?
Yeah, so as we were talking about, version control is really just trying to keep track of changes within files and new files, removing files. So any differences essentially. Any questions? Anything on Zoom, Peter? Okay. So, and if for some reason, let's say like in this README case, I don't want to delete the README. That was probably a dumb idea to do. You can discard those changes. So this is what nice in IDE, you have these graphical ways where you can do this, I don't know, undo button to discard if you accidentally deleted something, or if you want to discard something completely. But you can also undo specific line changes as well through the IDE. Okay, so that's the first part. We made our edits. Now let's actually see how we're going to go about pushing those files. So those last 3 parts. So if you want to now what's called stage the files that you're ready to now integrate into your main project, you'd press that plus button essentially. And okay, as I mentioned, you can discard individual changes. And then what we'll see after we press that plus is that now it's created a different category. Before we just had changes, now we have staged changes. So these are things that are being ready to be pushed. So I did the plus on python.py, and I can equally unstage it with the minus. Okay, so we did that first part. That's what we would call adding files or staging them. Now we're going to want to use, we're going to tag it to a specific commit message or commit hash. So essentially it's that we're kind of giving a unique identifier for this group of changes that we're going to propose. In this case, there's only one change, but you can group multiple changes. So I could have pushed multiple files, but in this case, I just pushed one. So here, again, through the same interface, I'm going to type a message. So in this case, I'm going to use something. Usually, I think the convention, I don't know all of the conventions, is to use imperative tense is one of them. So update print message. So that's what I've done. And then in order to now commit this and give a unique identifier to that change that I've done, I'll then press this commit button. All right, so that's committing it. And now to actually now push the commits, I'm not sure if there's another, maybe those of you who are also using VS Code. So the way I would usually do it, but maybe because it doesn't seem very intuitive, you have to actually go down to the very bottom of the page, and then there is this push is down here. Does anyone else do something differently if you're on VS Code, or? Yeah, you can do 3 dots and then push, but then you have to press 2 things here. Just press below, and so this will also pull the local ones too if you're missing out on anything. And then here we can see which are the commits I'm about to push. So here there's just a 1 because I only have 1 commit, but I could have had maybe 10 commits that I'm going to push. Yeah.
Just what is the state of the project when we commit before and still have not pushed? Did we already change something in the project?
Yeah, so we're still following the same example where I've changed the hello world to a small w. I've added the comma here. So the changes that I've made were what we saw here. And then I've staged only the Python file. So the new file I'm not adding, the README I'm not deleting. So that's kind of still there, but I'm not pushing it. So that's what this example is trying to show, that you can have things that have changed, but you're not pushing them.
Is it saved on Git when we do commit?
Saved on Git or on GitHub? So nothing's been done to GitHub until I do this push. So at the moment, everything is on my local computer. I've created a new commit in my local computer's copy of the repository, but it's not synchronized with GitHub yet. So now that's what this step is to push it so that GitHub has this commit and the changes associated with it as well. Okay, it can seem weird. Where is going each thing, but hopefully this small example shows it. So now I have this commit on my local computer, and I want to add it to GitHub's history as well. Okay, so then to push it, I would essentially press that button, and it'll say, oh, pop up something. This will pull and push commits, and I'll say, okay, I'm happy with that. And then you'll see now that all this stuff of outgoing and stage is gone, and now I just have the 2 changes which I haven't committed. And as I said before, okay, I probably want to put back my README file, and actually this is an empty new file, so you can discard all the changes with the similar arrow going backwards for all of them, or each individual file will also have that same discard. And yeah, so that's the whole workflow essentially. So the ID kind of gives you a nice graphical way of going about this and kind of having a visual of what are the different changes that you've done. Any questions on that? Okay. So as I said, I'll also show you how you would do it through a command line. So let's say you made your changes. One way you can then see what changes are made is if you do this git status. Then you can use git diff to kind of see what are the differences. You can do git diff, the file name, to see, okay, what are the differences in one file? And then those 3 steps of adding, committing, and pushing, they're more explicit in the actual git commands. It's literally you git add the file. You can do multiple files. You can add a dot if you want to add everything at once, which I don't recommend. Git commit -m, and then you would write your message like we did before in quotations, and then git push would then push the commits that you have locally that are not in the remote. And then if you want to remove changes like we saw with that arrow, you would do git restore the file. Okay, so that's via the command line. All right, now to kind of give you an overview of what are the different features of GitHub, maybe some of you have used it or not. So if you work with open source software, you'll see these tabs are where a lot of activity happens if on popular GitHub projects. So issues is where, for example, you can keep, where someone can declare that, okay, there's a bug here, or this would be a cool idea. Or I would also use it in my own projects to kind of keep track of different ideas that I think could be cool. So I would open an issue to say, all right, it could be nice to have this feature. So that's the issues. Pull requests is where you would actually contribute code into the code base. And we'll see an example of that in a bit. So we mentioned this idea of how people could be working on separate things, and then they want to bring it together into the main thing. And the mechanism through which you would bring it back into the main thing would be through a pull request. So you would work in a branch, make some changes, and then before putting it in this main branch that we're here, we would do a pull request from another branch to main. We'll see an example in a bit. So branch, so you can see what are the different branches by clicking on this drop down. And a branch just similar to, I mean, the whole idea of Git is just to keep track of changes. So a branch is only going to keep track of the differences in commits and from branches of each other. So here, for example, if I create a branch called Eric, it's just going to make a lightweight copy of the main branch, and then I can do all sorts of changes there without ever touching it or affecting main branch. Okay, so that's on branch. Fork is a way you can copy a repository. And then, for example, here, this repository is under my username. And let's say you want to make a same copy under your username, you would use this fork option. So they would fork it to Peter Blinerot. This is his username, GitHub username, Blinerot upgraded potato. And Blinerot is something with potatoes, no? You told me, or?
These crepes.
Oh, with crepes. Okay, never mind. Food related. So that's how he would have his own version. And why would Peter want to do that? Maybe I don't trust Peter with my code, and I don't want him to push code into my version of upgraded potato. So then I ask Peter to make your own fork, and then we'll see if you can merge some of your code into mine.
What if you can work on a branch?
Because if he can work on a branch, the way that the writes work in a repository is that he can probably touch main as well too. He can change the contents in main.
She's the one who is responsible for like second.
I am, but then if I accept him to write branches, he would also have the rights to change other stuff. And then maybe I can control it so that he can't write into main, but the fact that he can create branches means he could bloat my repository. He can make as many branches as he wants, and then it wouldn't make a clean repository. And Peter's a bit of a messy guy, so I don't want him I don't want him just yet in my repository. Any other questions? So this is how you determine who are your real friends. Who are you willing to give write access to your repositories, or who are you going to ask to fork? To fork off, yeah. So, okay. And then there's also stars, which this is the more social side of GitHub. This does not impact anything on your GitHub. Even fork actually doesn't touch your GitHub repo. Forks, stars, watching, those are just on the more social side of things. Okay, so I just realized now it says Obama means family instead of Ohana. I don't know if any of you have seen Lilo and Stitch, but so now we're going to see how we can work together. Because as you know, Stitch wasn't a very friendly guy when he first came to Earth, and GitHub is going to help Stitch be more collaborative while here on Earth. So if I wanted to add a collaborator, let's say, okay, now Peter has shown me he's trustworthy enough. Let's add him as a collaborator. So the way I would go about that is in this settings tab of my GitHub repo. So this would be the same place where you can change if his repo is public or private. So then there's collaborators option, and then you would search essentially for the username of the collaborator you want to add, and then you can add them with different sorts of rights. All right, so that's how you add a collaborator. Let's talk now then. Now we're working on the same repository as multiple people. People are trying to change the same thing, and that's what leads to these merge conflicts. And merge conflicts happen these are the two situations which you can kind of identify where they happen. Either people make different changes to the same line of code, or when one person edits a file, another person deletes the same file. Because otherwise, if you're working on completely different files, completely different lines, even though you did different commits, Git is going to figure out how to stitch those different changes together. But these are two different situations where Git is not sure who's actually right in this situation. So that's why there needs to be some manual intervention here. So I'm going to simulate an example here. And the way I'll do it, just to give you the context, is I've made 2 copies of upgraded potato. So that's why you saw I had V1 on my computer, but I also have a V2. And then we'll make changes to the same line and try to push to GitHub, and we'll see what happens. Make sense? All right. And then we'll see how VS Code helps to resolve these conflicts rather than manually going into files, manually changing things, and yeah. Okay, so let's say Lilo, so she's trying to work with Stitch on this project. She wants to change her this print message to say, my name is Lilo, how are you? So she then goes through all the procedure that we saw before. She adds the file, she commits it, and now she's going to push it with sync changes in this case here. So she's pushed it. It's up there already. Now it says, hello world, my name is Lilo. How are you? Stitch doesn't know that it says it. He still has, or it still has, hello world, my name is Eric. He replaces the Stitch. It replaces it to Stitch. He's on upgraded Potato V2. And he's done, or it's done the adding, committing, and now it's trying to push the change. But then, bam, he gets all sorts of things that pop up in his face. There's going to be there would be an error message down here on VS Code. You would have all these weird outputs, and then you would have this merge changes thing that appears up in the source control. And essentially, these different tags are just trying to say, okay, two people have tried to change this single line. Remote, so that's what this hash is associated with. So it's what's called or the incoming change is what Lilo did, and we see it. Hello world, my name is Lilo. How are you? And current change, so it's on his computer or its computer. Hello world, my name is Stitch. How are you? So now Git doesn't know, okay, which line should I take? Because you both tried to modify the same line. And what VS Code gives is a nice interface now to then actually go through. In this case, we only have one of these conflicts, but there could be many more. So you can get, or what VS Code will give is an interface to kind of go through each conflict to kind of resolve which is the best change to go for. So in this case, we can click on the python.py file, and essentially we'll see kind of this grayed out interface appear to us, where it says either you can take the current change, which is what Stitch wrote, or you can take the incoming change. Sometimes it may be interesting to take both, because maybe there's something useful in both of the lines, and then you want to kind of manually put them together. And compare changes. I don't know what it does differently from this, but okay. Those are the main three which I would work with. Either I take that one, mine, or that one, mine, or accept them both and try to figure out how to work with them. So in this case, okay, and one thing I forgot to say is that when you click on one of those, it's going to remove all of these weird tags of head, equals, and then the commit message. Because before you actually commit and push, you need to remove these things, because that's actually what's blocking the merging. So that's why this interface is nice, because when you click on it, it'll remove these tags and then do the changes you want. Or if you accept both, you can figure out how to stitch them together with those tags already being removed. So in this case, I've changed it to keeping, or Stitch has changed it to keeping my name is Stitch, and he wants to say, hello, Lilo, my name is Stitch. So in this case, you could have accepted, let's say, current change, and then I just changed world for Lilo. And then what we'll see is that, okay, this file is still under merge changes, and there's already a commit message that's filled in for it. But what I need to do is, since there's this M, I still need to add the file, commit it, and then I can push it. So that's what we'll do. Whatever files you have to change through this merge conflict, you need to explicitly add them again, type in this commit message, or use the one that's been provided, and then push it. And then it's resolved. Any questions? Yep.
This new file is again different from the one on the server.
Yeah.
If you push it, but the same thing doesn't happen.
So that's why it won't work if you just push it. You need to do a new commit. So that's why you're going to add a new commit on top of. So I think if I go to the history of where I was working, you can see what happens. So this is another visualization of stuff. So how do I see the Git history again? It's okay. So this was the merge commit where I just changed hello. And I guess the previous commit would have been Stitch's commit. So if I see there's two parents here where Stitch changed it himself. And then we see also Lilo's commits, but they're kind of been merged into one, and with a new one, which is this one, which has done world instead of Lilo. So you need a new commit for the merge in general. Yeah. I don't know if that answered it somehow.
So the previous one was not committed.
The Lilo's was committed.
Not the session.
Stitches, it's kind of weird what it shows here. I've never seen this before. It's adding the two. So they're both committed. This was Lilo's commit. Or this was Stitch's commit, where he just changed Stitch. And Lilo's is also there, but they're being added for this new commit. Or this has two parents. So actually it's its own commit in the tree. But we need this one to kind of for the, let's say, the commit history to continue forward, because otherwise these two are conflicting with each other. And its own commit tag is this one. So if Lilo wanted to go back, she could always go back to this. If Stitch wanted to go back, it can always go back to this one. Any other questions? Okay. So now we'll get to this concept of pull request, which is sort of a mechanism to help you avoid these merge conflicts, in particular on your, let's say, what people will call your stable code, which should ideally be what's called in this main branch. Because usually you don't want to, in practice, like if you're working in a big team, you don't want people to directly commit into your main branch. You'd be working, everyone would have their own branch where they're working on different features. When it's ready, then you would merge it into main. And that's what a mechanism like pull requests helps with. So what that means is first we need to create a branch. So from VS Code, the way you would go about it is you would, you see the main branches here, you click on it, and essentially it gives you an option to create a new branch. And let's say I wanted to create a new branch called Better Greeting, as Lilo and Stitch should have done. And then you can manually click on create a new branch to do that. And then you'll see from VS Code in the bottom left that, okay, now you're on this new Better Greeting branch. And let's say I want to make some changes to it. So before we had hello Lilo, comma, I'm going to add an exclamation mark, hello Lilo, exclamation mark, my name is Lilo, or Stitch. And then I've skipped a few steps here, but essentially now we're again at this place in the source control where we see the modified line. And then we're going to go through the process of committing it. But the problem is if we try, we're not going to be able to directly push it. VS Code is going to tell us actually this branch doesn't exist because I've only created this branch locally on my computer. And it's going to say, okay, do you want to publish this branch actually with this new commit you've done? And yes, we'll go ahead to do that. And then what's nice on the GitHub side of things, when you create a new branch, it's going to have this small pop-up appear at the top of your repo saying, okay, there's this branch which has some new pushes. Do you want to compare? In this case, it's going to want to compare with the main branch. Do you want to compare and make a pull request? Maybe you wouldn't do it right away when you've started a new branch, but in this case, we'll do it right away and we'll see what's the process of creating a pull request. So this is useful if you're working on the same project as someone, or if you've forked a popular library and you want to make a contribution, you would open a pull request. So when you start a pull request, essentially the couple things to keep in mind are, okay, where you're trying to merge it into. So in this case, I'm trying to merge into the main branch, and I'm doing it from this Better Greeting. And these could also be on different forks. So for example, if Peter was using his fork, this Better Greeting could be under his username, whereas main could be under my username. Even though he doesn't have the right to directly write, he can still create a pull request into any public repository anywhere out there in GitHub. So that's one thing to keep in mind. And then also good practice is to write a nice title, write a nice description about, okay, what are the actual changes that you're doing? And sometimes some open source projects will have a template that gets spit out directly here where they'll ask you, did you run the tests? Did you follow some formatting? Did you try this and this? And then they'll give you like a little checkbox where you can make sure your pull request is ready to go. Here, there's nothing, just simple for this example. And then on this collaborative side, you can also add people if you want them to review your code. So in this case, I'll add this guy who none of you know, but it was from a previous tutorial. Let's say I want to add him as a reviewer. And then what's nice in the code review is that, okay, you can see all the different commits that you've done, and then all the files that have been changed. Here, only one file has been changed, so it's not interesting. But there's still something interesting where if I go to the, so it's hard to take the screenshot of this, but you can comment on individual lines, which is super useful when you want to kind of share your input or feedback to other people. So let me just switch to GitHub to show you how that looks like. So let's say I was at this pull request. I go to the files changed. When I hover over there, you'll see this blue plus pop up. Here it's kind of silly because there's only one line everywhere. But imagine you had a bunch of other lines, and you can comment on one line to say, okay, maybe it's better to ... So for example, if we go back to the situation, let's say where you're sending your files over email or WhatsApp, instead of having to then just write comments on WhatsApp or email, where they had to figure out, and you have to say, okay, at line number XXX where you were trying to do this, you could have done this. Here you can literally write where that code is and write a comment on it. And this is super useful. Or for example, one thing I find myself doing is, say if I go to a file, you can copy a line number, and then maybe I'll share that link over Slack or something. And then when they go to that link, essentially it'll take them to that line. Here again, it's a bit silly, there's only one line, but if there's like 500 lines, it's super useful that you can get a link to that line and take them there. Or if you're commenting on code, you can comment on that specific line of code. So this is nice on the review side of things, where you can comment on specific lines. So if you want to ask your colleague or boss or someone else to give feedback, they can give more, say, more directed and targeted feedback in that fashion. All right. And so any questions? Yeah.
If the branch does not exist on the server on GitHub,
Mm.
But what if the branch that we created has the same name as the one already exists?
So if you've been synchronizing enough, it would realize it. If you haven't, what it would do in that case, I'm not sure. I think it would give an error, I guess, that this branch already exists. But you have had to have been offline when you created that branch. So I'm not entirely sure, but yeah, it would have, some error message would come up. I could try to simulate it later if you want to see, but it's kind of a rare incident that would happen. All right. So another nice feature on the pull request side of stuff is that, let's say whoever was reviewing this one line had lots of requests, and then I had to make 10, 20 commits just to make this person happy. And those 10, 20 commits would make my Git history very messy. So one nice feature that you have on GitHub is that before you actually merge that changes of code, let's say you only change 2 lines, but then for some reason you have to do 50 commits, you can squash all of those commits into a single commit in the history of the main repository. So this is nice just to avoid having many commits or a lot of commits that just said, try again, try again. I don't know if you ever do commit messages like this, like, oh, it didn't work. How about now? I don't know. Sometimes you do that, and then you can get rid of that ugly history with this squashing option. All right. Any other questions on pull request? Yeah. Yeah. Yeah, so the question was, if we're working locally, should we we're using VS Code, do we need to use GitHub Desktop or command line or anything else? No, so you'd only do committing from one platform. So either from VS Code or anyway, you wouldn't be able to do the second commit again. There wouldn't be that option. They would already see the files as changed and committed. So you only need to do the commits from one platform. Any other questions? All right, so there we saw the case where, let's say your collaborators were on this, all had write access, so they could make changes to, in this case, eBESM, upgrade a potato. In the case where, as I mentioned, where you're not going to give write access to this person, maybe it's some random stranger on the internet, or it's Peter, then you're going to ask them to instead fork the repo, which means essentially to make a copy to their account. And the workflow I would recommend, if you're ever forking someone else's project, probably some open source project or whatever, is okay, first you do the fork, make a branch from the main. So don't do your changes in the main branch, keep that clean. Branch from the main, maybe make your own branch. Locally, you would clone this fork, and locally you would work on this different branch that you made. And the reason I say it is because maybe while you're trying to make some changes, the original, let's say, maintainer or developer of that project, they make changes to the code. And then that means, okay, and maybe those changes make something more efficient with the code that you're working with. So then you want to merge those in. But the problem is if you've made changes to similar lines of code that they did, you're going to get into some sort of merge conflict. So what I like to do as a good workflow is I keep this main branch clean so that I can just keep that in sync with the original code. And I work in a separate branch, almost as if my fork is the real repository, but it's actually only a fork, but I'm still working off branches. So it's a similar thing like if you were working in the same repository, that you wouldn't touch the main, you would just work off of branches of the main. Does that make sense? Otherwise, I'll practically show that a bit. So yeah, Stitch is a bit confused. So let's show this. Okay, so now you can use your laptops if you want. So this will be our transition into the Python side of this workshop, where so Peter, you put this on the Discord already. So you can go ahead and fork this, and essentially that will create your copy of this branch. And then I'll just show the steps that Stitch should do, like where you fork it and you make a branch from the main branch of your fork. Okay, so
So on Discord, it's on our main GitHub repo. If you go to day one.
okay, so it's there. Otherwise, here's the link. So you're already on the slide, so you can click on the link. So the idea, okay, you find a project that let's say someone's doing something around computer vision or NLP or audio or something that you want to copy. So you'd probably, I guess, you would go to their project, you would fork it. And then from your fork, so here I've done a fork on the LauzHack account. You can actually also, we saw how you can create a branch from VS Code, but you can also create a branch from GitHub itself. So in this case, the way you would go about that is that you click on that drop down for main, you can write the name of your branch. So usually if I'm, let's say, working with a code base and I don't have a specific feature name in mind for that branch or that thing I'm working on, I just call it, my name -dev, so that they know, okay, this is the branch that I'm working and developing on. So here I'm just going to create a branch called Eric Dev, and essentially then you can just, if that branch doesn't exist, it'll prompt you if you want to create this branch from GitHub. So that's what I'm going to do in this case. And then now we're going to do the same steps that we saw before. I'm going to clone my fork of the repo, so not the original one. So I go to clone GitHub repo. And then instead of looking for my username, Python Dev Tips, now LauzHack Python Dev Tips should show up as well. Since anything that's public, you'll be able to index it, and you can be able to clone from there. So I'm going to clone this. Again, I pick its location, as we saw before, save it somewhere. And then what it's going to do is actually going to default, but put me in the main branch. And in order to switch out of that main branch, then I'll just click on main, and then I should see origin. So origin just means, okay, the remote source of this repository, which is on GitHub. So then it's giving me the option, either I can switch to that or the main branch, which I'm already on. So I'm going to switch to origin _ Eric Dev. So those are the steps. So we saw fork on GitHub. You can make the branch on GitHub or on VS Code. So steps 2 and 3 can be interchanged. Clone. So here I clone the GitHub repository, picking my fork, and then I switch to the branch to make sure I'm working on the right branch. And then, as I mentioned before, so I mentioned this idea that, okay, I keep this main branch untouched by myself, so that in case there's changes from the main developer, I can synchronize with them. And what's nice is that GitHub gives a nice interface to synchronize your main branch with the original main branch. And what will happen is that if you go, let's say here I had the forked version of Python Dev Tips wasn't sync is out of sync with the main one. So we can see here it's 5 commits behind the original one. So essentially, they have this nice graphical way where you can just click on this drop-down button for sync fork, update branch, and then it will be synchronized. And then you can then merge your main into your branch and then deal with any conflicts that are there. So that way you always have a clean version on your fork, so you don't have to deal with the merge conflicts, at least in the main branch. So that's just like a tip to avoid, to make conflict management easier. Any questions there? Okay. So in summary, so just to wrap up the Git side of things, so GitHub gives a convenient platform to host and discuss code. Some of the terminology that's important to keep in mind is branching from, let's say, a core code base to prototype ideas without, breaking the stable code. Issues to keep track of bugs and ideas. I'll go to GitHub to show that since we didn't see any example of that. Pull requests to kind of incorporate, so you can have as many pull requests as you want. So I forgot to mention that you can have 50 that are ongoing at the same time, so that many people can be working on different things. You could be working on different things and trying to incorporate into the main code base while you're waiting for feedback from other people. So let me show the issues aspect really quick. So really in issues, these are super easy to create. And then usually there's no code associated with an issue. So maybe you can say, prompt a response from the greeting, because all we're asking is, how are you? And people may just say, okay, it would be nice, blah, blah, blah. But then you can also add code. So there's essentially everything you have here is markdown syntax. So I could do this sort of syntax to then write import numpy as np, and let's say h equals np.ones. And then you can do preview to see what your messages would look like. So on the pull request and also on the issue side thing, it's all marked down. And if you don't remember these, I think you can also use these shortcuts where if I did code here, okay, that would just do in a single location. So not a code block in that case, but yeah. You can add files, you can mention people. So I can add Lino wrote, I don't know if it recognizes him, but here then I can see if it actually goes to the right Blino wrote, and it does. Yeah. So yeah, that's issues is more freeform. You don't necessarily need to have code associated with it. While pull request is always kind of merging one branch with another, so it's usually involves some sort of code with it. All right, any questions? All right, let's just take a couple minutes break. I need some water to refresh myself. I'm just gonna get a glass and I'll come up. Sounds good? Take a bathroom break if you need as well too. Start with this next bit then. So just kind of give you the outline again, because I don't think I gave it here, but so yeah, most of you seem from, I guess, the hands I saw comfortable with virtual environment creation. Does anyone want to see more into virtual environment creation, or it's okay? Okay, good. And the more interesting bit will be, okay, this configuration management, because I guess this will come up in the templates that Peter has. He's also using Hydra. And I think a very popular toolkit, which I'm not sure if you show, but there's this Hydra PyTorch Lightning. Do you use PyTorch Lightning in your? Okay, he hates PyTorch Lightning, but you don't need to use but Hydra can be used either with normal PyTorch or PyTorch Lightning. But it's, yeah, very great library to use, not just in machine learning, but anything that involves experiments with many parameters. And then we'll look at different popular useful Python libraries, talk about packaging if you're ever interested in, okay, how do you make your code pip installable by someone else? Yeah.
Number 3 and number 5 is the most important. So if you will be out of time.
Okay. Yeah, 6, actually there's nothing there. It's just that there's more there. So we'll focus more on these parts. So yeah, let's go. All right, so yeah, as my friend in the front was mentioning, you can give me a little star if you want for my Python dev tips. Yeah, bloody bloody. We know Python is getting super popular, probably even more now since in 2024 with all the boom in AI and deep learning. A lot of people still wonder about the differences between why you would go for Python versus MATLAB. Yeah, here's the pros and cons. What's funny is that this is coming from MATLAB itself, I think. Some of these. Yeah, there's a nice article from MATLAB where they say, okay, we're trying to give you the best support possible. Please buy us. But Python essentially it's free. There's many tools to do the same thing. And as a result, you kind of get this survival of the fittest. So you kind of get the best of the best that kind of comes out from this friendly competition. And then it's better at keeping up with the most recent trends, especially in a field like machine learning, which I don't know, like every couple of days, you probably have something new coming out, or at least every couple of months, you see like there's an even better architecture, even better performance. So Python, because of its flexibility and its open source and freeness, is better to keep up with these trends and why you have all this buzz around it. Let's say the two parts of Python that because of this, the way it moves quickly, that it's kind of makes it a difficult thing to work with, are this notion of dependency hell, where you can have different packages which kind of conflict with each other, which don't work with each other. And then you'll have maybe poor documentation. PyTorch luckily isn't one of those because you have Meta, Facebook, who's behind it. But let's say lesser known libraries, which are maybe developed by a research lab or a university, may not have as much support and documentation. So that can be sometimes the frustrating part of working with Python. And kind of the goal of this workshop is to show how can you kind of make this side good in your workflow so that when you share your code, it'll be easier for other people to use and more structured, and you can foster more collaboration now that you also know everything about Git and GitHub too. Okay, so making your Python life easier, we can go through these quickly. Spoke about this dependency hell, and essentially the solution for this is to use virtual environments, which I guess most of you are doing already. So kind of making isolated Python environments which has all the packages you need, because maybe another project would require, let's say, maybe it needs a different version of PyTorch or a different version of TensorFlow, which now there's 1 and 2, or a different version of different packages. So virtual environments are useful for that. So I just give 2 ways you can create virtual environments. One is either through Conda, which you're using Conda mainly, I guess, Peter, for your templates, or?
Both speed, both from the way poetry.
Okay. I remember you mentioned it to me, but but Conda is a good one to kind of stick with. Essentially, the main difference is that Conda will have, they'll have versions that are kind of compiled specifically for a particular machine or OS. So it's usually better to use Conda so that you get the version of a software that is best to use, let's say, with the Mac M2 or like Windows or I don't know what. So, yeah.
Say one thing that you can create virtual environments using your Python, like which you install your Linux or so on. But the good thing about Conda is that you can install any version of Python that exists, even which is higher than the one on your Linux, and it can also download some packages like GCC, OpenSSL.
Yeah, it's not just for Python packages. So
I had this problem myself and moved to Conda. When you work on a field server, for example, the packages might be old. And with Conda, you can install new packages, new versions, and you can work with newer Python. Just because Conda has its own packages and less problems. With PyEnv or just Python, which are another alternatives, you should update packages yourself, and sometimes it's pain. So,
I have a question. Usually I create like environments in Conda, but then I start within this Conda environment. So how am I seeing it? Like this like clouds?
yeah, that's fine. You can still use pip within a, because maybe some packages won't be on Conda, so you'll still have to use pip. Yeah, it's fine. But for let's say these these really compute heavy frameworks like PyTorch, TensorFlow, use Conda to install it. Or yeah.
You can use pip.
You can still use
So
pip, but
everything, just some packages doesn't say that they proper check pip versions, or they doesn't proper check Conda versions. And one thing to do is avoid mixing Conda and
Is that what
pip.
I'm saying? I'm good at mixing some.
You can install environment via Conda and then install packages whatever you want, but don't install some packages using Conda and some packages using pip. There's a use Conda people.
but sometimes you have to use pip because there's not a Conda version of it from some very small like niche packages.
You might get problems because you mix one out of two.
Yeah, you could. Hasn't happened so much for me, but it's okay. But it's better to stick to fully Conda, fully pip. Was there another question or? Okay. Because another thing you can do is actually you can install a GitHub repo through pip, which sometimes I find myself doing this if there's they haven't packaged it, you can still do pip install and you can give the git URL. There's a syntax for it, but yeah. You can also create environments in VS Code, which I've never done. I was trying to figure out how to do it yesterday. It didn't work, but there's somehow a way where if you click here and create virtual environments, you can pick which type of virtual environments, which Python you want. Then it crashed for me at some point. So I something in my setting wasn't right. So I just stick with command line versions for creating virtual environments. Maybe it works for you. So I put that there. So some advantages of using an IDE, so we mentioned this, is it has this indexing of variables and classes. So Peter was showing this class-oriented thing. So I have inside Python dev tips, I have a class where you can then rename that class everywhere else. And so that's a nice feature. It'll highlight occurrences. So let me show it from the code itself. So if I'm in that's so like what I was doing was essentially here when I click it, it highlights everywhere else that it's used, then can then rename the symbol everywhere. I don't think I'm in the right environment. Here we go. Yeah. Was there a question there or no? Okay. So that's useful when using IDE. Debugging, so I'll just show it through the slides. So and I know all of you are doing print statements when you debug. You shouldn't be doing that. You should use a debugger because then you can actually interact with your variables. So how would you go about that? So if we take this same class, we can put a breakpoint on the line where, let's say we're not sure if we're doing the computation correctly here. We're receiving this input and I want to know that I'm doing the right type of transformation on it. So I'd put a breakpoint there. Make sure first that your correct virtual environment is set. You should go to the script. So you shouldn't run the debugger from this file. Yeah, you have to build hard. No problem. So if I wouldn't be able to run the debugger from this file because there's no function or no script that could be debugged. But I go to the file where I'm, let's say, calling this class, and then there's this little drop down near the play button where you can do run debug file, and then essentially it'll run and it'll stop at that breakpoint which we set before. So right there, highlighted in yellow, and then so I stopped at that breakpoint, and then in the bottom we have this little terminal where we can interact with the variable. So for example, here I can write self.filter.shape. So we saw like what Peter was showing. If you want to kind of debug to see if you have the right dimensions, the right number of dimensions, the right shape of a tensor, that's where it'd be useful to use, very useful to use debugger rather than having to print each time, let's say filter.shape, and then you have to retry. Using a debugger will really save you time. And then you can also plot things through this debug console, which could also be useful. Like if you were working with images, you would first, reshape it to the channels at the end, as we saw. You would do, in this case, plt.imshow if you want to plot the image to see, okay, let's say if you were playing around with different augmentation techniques, you want to make sure the augmentation is working like you're expecting to. So then you can do that there instead of having to launch your training script, print, and then Control C to kind of see things. Here you can really debug and kind of avoid those iterative running of your training scripts. So let's say you're happy with what you've done. Under this run thing, there's different options. So in this run drop down, either you can kind of continue into the next steps. So that's the step or continue. You can stop debugging altogether, or you can just kind of run without debugging, which means, okay, just continue the training script. Okay, so that's it on debugging. Anything on that aspect? But at first it seems annoying to use if you're just so used to just doing print statements, but really highly recommend to use debugger. It's especially, okay, if you're going to do training scripts, which maybe it takes like 2 minutes to get to the point where your debugging stop is, like you're going to be saving, okay, I don't know, 2 minutes times how many ever times you're going to try to run that script. So it'll really save you time when you get to more complicated projects to be comfortable with the debugger. So I recommend getting comfortable early on. No questions? Okay, so extensions and plugins. So this is another really neat feature, which is in VS Code. I guess PyCharm, you can also have plugins like this. So we already saw some of these tabs, the File Explorer, Source Control. This is the debug one, which, okay, we kind of got in, we were inside in the last few slides. And in extensions, you have all sorts of stuff. For example, for Jupyter Notebooks. One thing that's super useful is GitHub Copilot. How many of you use GitHub Copilot? Okay, this is super useful, especially if you're doing ML stuff, because it knows ML code super well from all the open source stuff there. And it can, I would say, at least boost your coding productivity by 5x, at least, I would say. So for example, you saw that code in PyDev tips, which was like this. Most of it was actually written with Copilot. That's the source code there. So it, from the way I've defined my class, it realized, okay, you want to do some sort of filtering, and you need to use the FFT. So then what happens is when you have Copilots enabled, so the way you would know is that you have this little spaceman down here. So he's enabled, and then it'll be like an autocomplete, where essentially it'll propose all of this stuff in gray, and then essentially I just have to press tab if I approve of it. And usually most of the time it needs some fixing, but already what I find it very useful, as the name says, is a copilot. So it's suggesting something which is going to be useful. So I usually accept it, I make small tweaks, use the debugger, and then figure, okay, if that's what I wanted or not. And then this can also save you time. Like, I guess most of you have then used ChatGPT, where instead of having to go between ChatGPT and your code, you really just have it in kind of neat one workflow where you have the code suggestions where you're working. And yeah, saves a bunch of time. So
say that you should try to avoid Copilot and then just try to learn stuff.
yeah,
Because you won't know anything if GPT will do it for you. But if you already know how to do it, it's good to simple.
yeah. And what it's also really good at is when you have a big code base and you've defined your own functions, it's already kind of indexed and has the context of your other code and your other files. So then it'll be able to save you time when you have to kind of like use your own methods, and maybe you forgot, okay, what are the order of arguments? So, but it could still get it wrong, but it helps as an initial thing. But it's always good to have a grain of salt when you get its outputs, and like, okay, it's probably wrong. Let me see how I can fix it up. And there's other versions. So I don't know if this company still exists, Mutable AI. Amazon has their own thing, Code Whisperer, which I think is free. But Copilot is free as a student. So if you sign up for this GitHub student pack, you can have free access to Copilot. And I think otherwise it costs $15 a month. I don't know, but 10. And it's really good for documentation. So we were talking about how a lot of Python packages don't have good documentation. So you can avoid that with yours by essentially using Copilot. So let's say you've defined so now you're kind of seeing how I built up PyDev tips on the code side of things, where and documentation side of things, where at first I wrote this or co-wrote this with Copilot. And then I said, okay, I wanted to add the documentation to this. So I just added these 3 quotation marks, ... started typing real ft conv, and then I did ... or quote parameters, and then bam, it already knows I mean, this is an easy problem for it. It knows that these are the parameters. It can figure out from the code what type of parameters it is. So it pretty much is able to spit out the proper doc string for these different functions. And there's one nice quote I saw: documentation, even to yours, is like a love letter to yourself, because you'll be so grateful to see this when you come back to your code later. So yeah, think of your future self, and then how much you love that future self of yours. So yes, you can get your documentation really quickly through Copilots, and a lot of nice formatting of it as well. Another tip for using Copilot is and this is probably how you would want to go about coding something. You know, you're not gonna, or we all do it, but it's good to kind of think about what you want to code first, and then you go write the code. And then Copilot actually works best in that sense, where you kind of give through comments what you want to do because you've thought about the problem you're trying to solve. So in this case, this example script I wrote or co-wrote essentially with comments, where I said, okay, I want to create a signal. I want to create a moving average filter. I want to use my convolver that I've defined elsewhere. I want to do this convolution, then I want to plot the outputs. And most of this I only wrote the comments, and then Copilot spat out the code. I just had to do a few tweaks, maybe for the titles, maybe didn't get the arguments order correct for my class, and I just wanted to change the length of this. But then most of it could then spit out just from the comments that I gave. But again, it needed me to kind of give the prompt to say, okay, what do I want out of this output? One thing it works really great for, which I hate so much in coding, is indexing things. And then this thing knows how to index super well. Like, okay, how do you take away like things that you've padded it with, or shifting things? And so that's a great thing to, and all I do is just write in the comments, okay, take away the padding, and then it just takes away the padding. Or add a new dimension, like all the stuff that Peter was showing about reshaping and squeezing, unsqueezing. You can just tell Copilot to do it, and then it'll figure that out for you. It will drop what? No, I mean, you still need to know what you want to do. So that's why it's useful to then know, you still need to know the architectures and stuff. Because it's true that you could actually ask Copilot, write me a residual neural network, write me a CNN, a residual block. It'll do it for you. And the UNet, and yeah, you can do it without coding it yourself.
The idea of the course is that you can already definitely use some preparing stuff. What to do, which preparing model to do. In order to optimize the performance specifically for your task, you need to know how to train models for the page, how detectors are designed, and so on. Copilot, what's the course?
Copilot will be really useful when you want to also then prepare like your experiment scripts or your training scripts. And yeah, it's a nice starting point, but always think of it as like a starting point to then continue. All right, let's talk about Hydra. Who's used Hydra? Only you, Peter? Okay, this is one of my favorite tools. So the way I like to think about this, and this is especially the case in machine learning, is that let's say you have a training script or any script or experiment, and you have all these parameters. What are some of the parameters we saw before? We saw you could have the learning rates, you could have, I don't know, this weight decay thing, you could have, let's say the number of, we didn't necessarily talk about that, but the number of, let's say, components in your neural network, maybe the different types of augmentation you want to do. You could have.
You can just say that model architecture itself is a kind of hyperparameter you want to choose between 5 different architectures.
So the thing is, you could have so many parameters, and maybe, okay, the conventional way that people go about things is that, okay, they would have a script where all these parameters are at the top of their script, right? So let me already give you an example of one reason why this is bad. So if we think about our Git stuff that we learned about, let's say we're all trying to work on the same training script. We're trying to figure out different hyperparameters. We're going to get so many conflicts on our script, right? Everyone's going to be tweaking different hyperparameters. So one thing that I like about Hydra is that it explicitly tries to separate hyperparameters from code. So you're going to say, all these hyperparameters, let's put it into a separate file. So that's what Hydra lets you do. And so then maybe you've gotten a step further where, okay, you use something like argparse or click. Do any of you know these tools, argparse? So argparse is a way that you can, let's say you have a Python script where you run, I don't know, Python example.py, and then you can pass arguments like test equal 1, learning rate equal 5, whatever. You can pass hyperparameters through argparse, lets you do something like that. So Hydra gives you that for free, essentially, when you do this separation. And then instead of having to define a command line for each argument, actually, you just have a one-liner to get to this command line arguments. So we'll show that in a bit. And okay, third point, which is mentioned here, is that whenever you use Hydra, it creates these output folders where essentially it's going to keep track of all of the hyperparameters you used for that experiment, but then you can also save outputs in that folder. And then another reason I like it is because I hate Jupyter notebooks, because I feel like you probably run into this issue where you ran some cells in the wrong order and all of a sudden a variable doesn't exist anymore and you don't know where you've changed it. And for that reason, I prefer just using scripts where you know everything is kind of installed. Okay, for exploration, I would use a Jupyter notebook, and then for demo purposes, but like to run a training or an experiment for machine learning, I wouldn't use a Jupyter notebook because you're going to lose track of stuff, and it's better to do it in scripts with something like Hydra. So it's a lot of stuff which it's hard to really see the utility unless you actually put it into practice. And I've tried to also prepare this blog post where it kind of highlights those different things. But we're going to look at it now in a very kind of toy example, which doesn't really show all the benefits because it's a simple example. But when you get to a larger machine learning project, as you might in this bootcamp, you'll see the utility of it. So to show you about this, let's say, command line interface, with argparse, essentially, you would have to add, let's say you had 20 hyperparameters. You would have to have essentially at least 20 lines per hyperparameter. With Hydra, you just have one line for all of those 20 hyperparameters. And the reason is because I'm actually defining a separate file called defaults in another location where it's reading that file from in this configs folder. So inside that defaults.yaml files, that's the extension that's used for these configuration files, you can define all sorts of parameters. Like here, I only have 3 parameters where I'm setting a random seed, signal length, the length of my filter, but then we could have all those different machine learning hyperparameters that we talked about. Here's some optional stuff for logging purposes. But then essentially, let's say you have this default file which has maybe, let's say it has 100 parameters. Let's say you're only interested in changing the learning rate, right? Or interested in changing another 2 parameters in optimizer. So instead of having to write a completely new file with 100 parameters, you can actually inherit from another file. So here I'm inheriting from the defaults. And let's say I want to change the learning rate to change it by a factor of 10. So I just only have to define that one learning rate. And the rest of the parameters are going to be defined in that defaults. And so this output folder stuff is essentially what is that third point I was mentioning, where it's going to create a timestamped output folder where I can then save my results. So in this case, I was running this script, Python examples, real convolve pi. So let me run it from people walking on the roof or so. I'm going to keep that. Not debug console term. Sorry. Okay. So the example I want to run is this real convolve. I've defined its config here. So I have essentially these 3 hyperparameters. And let's say the way I run it, Python, examples, real convolve. And so when I run it, okay, so this is my input signal. I'm essentially applying this low pass filter to make it smoother. As you see, it has less variations. And then what's nice is that when I go into this outputs folder, I can see that same outputs. And then I can also know what parameters I used to run that mini experiment. So for example, if I'm running all sorts of machine learning experiments, and then I have some really nice outputs in one situation, like here, I have some, let's say these were some loss curves and it was all going down. Like, oh man, what did I do to get those good loss curves? Then I have right here all the parameters I ran for that training. So then I know, okay, I can really match and be able to reproduce those results. Yeah.
If you run it 10 times with different parameters, will it create 10 different folders? Or?
Yeah, so if I run it again now, actually, it'll make a new folder. Let's say if I wanted to change the seed equal 10. I have an issue here. As with this instantiate, do you remember how what we changed with this, Peter? Signal is not key. Signal is not instruct. Or maybe let me try changing another parameter.
Can you show me the
So while we look at that, essentially what it will do, I mean, we already see it happening here, is creating a new folder for each time I run the experiments. And then each time I run it, it's also saving, okay, how I've changed the different parameters. So here I tried changing this seed to 10, and whereas before it was 0 there. And then there's a way, I don't have it in this example, but you can specify a list of parameters you want to sweep over. And then I think it would create a separate subfolder for it, but I need to check again.
Can you show me its defaults?
The default one, yeah.
Lines.
You want-
It's the first lines of yeah, so it has because you saved as defaults, it should be defaults, not as default.
I think I typed something by accident, maybe. Oh yeah, that's why it's in yellow, actually.
Now it will work.
That was the issue. So if I run seed 10, then it's going to do that same experiment, but with a different seed. Then here I have, I guess, a slightly different result than from what I had here. Yeah, all random numbers, but then at least I can know which configuration I ran to run that experiment. And then I think, when do you show 1 dB? You show it?
In 1 dB, it will show 38, 1 dB itself.
So, but when is on Wednesday you show?
Thursday.
Okay, so on Thursday you'll see another package which helps you track experiments as well too. Which then, yeah, it kind of does the same thing as creating these output folders, but it doesn't provide this command line interface, which is nice to then try different stuff through there, while only having a single line here. Okay, any other question? Yeah.
Is this self? Is it self? The line self.
Yeah, so for defaults here, defaults as default values that you have.
It's kind of giving the order, I think, of where to look for the parameters.
Yeah.
So it does
So it does defaults and then it looks at self.
So
So then, since both of them define, what I understand from, since both of them define filter length, it's going to take the last one.
So
you can put self at first, then it will use the variables from your main config and then override them with the values of default. And if self is located below default, it first will read the values from default and then override them with the values in your main config. Okay?
So you could have, I never done this, but I guess you could then have 5 different files here. Or maybe you have some defaults for learning rate, defaults for something else, if you want to split them up, or yeah. So it's, I guess the way to think of it is it's a configuration management tool, but then it has all sorts of other perks in terms of command line interface, outputting folders, which helps for reproducibility. Yeah.
If you want to just feed some parameters, how do we do that? Just for command line? Something or example for you, or is it another efficient way?
I mean, there's multiple ways you can do it. What's nice about this YAML structure is that you can define lists, you can define lists of lists, because through the command line that can be tricky, or through argparse, you may not be able to easily do that, but you're more flexible in what you can define as inputs. So then you can just do it. You can define a list in your YAML file to then do the parameter sweep within your script. But there's also a way to do parameter sweeps from Hydra, but I don't remember the syntax of this. Yeah.
But the problem is that in deep learning, you will probably never do this because one training will take you so long that it's easier to do everything by hand. And then you can just change in command line, pick the random one value, then pick another one. So,
example, you want to run different experiment on different cores and want to see which one does better.
If you have if these experiments are fast enough, then you can use MongoDB sweep or Highland sweep. We won't show them, but you can go Highland sweep. But usually deep learning experiments are so long that it's easier to avoid the sweeps and just do everything by hand. Okay.
Yeah, and then having a command line interface lets you then just input those commands manually, or you can, what I do sometimes is I just define a bash script where I just put all my Python commands one after the other. Yeah. So yeah, I mean, I like this in terms of just keeping track of what's worked, especially when you have lots of hyperparameters that you're trying to work with, that you can always just go back to the config file to then see. And yeah. So I'll go, I have 10-ish more minutes. I'll go through some other interesting libraries. So we kind of talked about broadcasting in a way when Peter was mentioning this thing about adding these invisible dimensions. And adding these invisible dimensions allows you to then perform operations on things that are not necessarily the same shape. For example, if you're adding vectors, I guess it's obvious that you just want to add the vectors rather than looping over adding them. But if you want to add, let's say, I can do it here. So let's say you have. Let's say, yeah. So let's say you have like even more, right? Oh, you don't see it? Good. So this is a silly example. Let's say you have, I did it too long of a vector. You have this 1D vector here. And then you have a 2D, let's say this is like n. And then this is n by d. So it's more, instead of, and you want, let's say you want to add or subtract this vector from, each row of d, instead of looping over and then trying to add or subtract, it's good to do what Peter did, which was add this invisible one dimension to this thing. Let's say this was x, and you do unsqueeze. Unsqueeze 0 or 1 to add that dimension plus y. Because if you didn't have it, this original thing is 2 by nothing, and this one, or no, I'm just imagining numbers, is n, and this is n by d, and this unsqueeze adding is 1, so then you can work on those two dimensions with these two things. So then you can just literally do x unsqueeze 1 plus y instead of looping over y and adding x. So it helps you speed up things. And that's what this kind of examples are showing here, where if you apply things on a specific axis, or broadcast things, you can speed up operations. And this is just using NumPy, but you would see the similar types of improvements, I assume, with Torch. So that's one thing, because the idea here is you want to avoid for loops, essentially. So these are tricks to do that. Another useful tool that I use is something called joblib. So all these links to example scripts you can find in PyDev tips. You can run them yourself. So joblib essentially lets you to parallelize things over multiple CPUs. So for example, here, what am I doing? I am, what is fseed? So I'm applying some function essentially, which each application of this function is independent. And instead of doing it once and then waiting for it to finish and doing another one again, and then doing it again, and then doing it again, I can just run them all in parallel on multiple CPUs to kind of just speed up the time. So essentially your speed up will be dependent on the number of CPU cores that you have. So one example that I would use this, like in the job I had before, was we were doing a lot of, so we were working on speech recognition, and we wanted to do augmentation, like what Peter was showing. And we wanted to take a single audio file and kind of simulate it in different rooms. But each room is kind of its own different problem. So then we can do all of those simulations in parallel so that we can kind of speed up this pre-processing step just in parallel. You can also do it across multiple GPUs if you're using PyTorch too. But here's a way you could do it over CPUs. And on GPUs as well, so you could use PyTorch to do GPU compute. You could also use something like QPy. So Peter was mentioning how PyTorch, NumPy have relatively the same APIs. QPy has even more similar API as NumPy. So it's kind of like the NumPy version, or the GPU version of NumPy. And then you can see these different types of speedups depending on the operation. So again, I have an example script. And the way that people typically use is that, let's say you're trying to do like a Fourier transform of an input, you would feed the inputs, and from the input, you try to determine what type of package or module it's coming from. Is it from NumPy or is it from QPy? And then you just apply the corresponding function. So if it was NumPy, you would apply probably the SciPy FFT. If it was a QPy array, you would apply it on you would use the QPy FFT. And then you can also add like a third line if you realize, oh, this is actually a torch tensor, then you can use the torch FFT. So this is one trick where you can make something compatible for GPU, CPU, PyTorch, NumPy. So you can see the code on what this get array module looks like if you follow that script. And then yeah, I guess as you can expect, the GPU, you can get some pretty fast improvements performance. All right, so spend a few minutes to talk about packaging. So let's say you worked on this project with your collaborators. You've followed some good tips and tricks to make some efficient code. So now let's make it available to other people. The first part, and this is actually, you'll see, especially if you do pull requests, that is important, is to conform to what are called these code formatting style guides. So essentially, there's this PEP 8 style guide, which is like just common conventions on how you write Python code. So for example, you'll see that functions, they'll usually have lowercase, classes, they'll have this camel case where you have capital letters for each word. And there's different conventions, and also how you do the new lines and how you do the spacing. And no one's ever going to remember it. So essentially there's tools that format your code for you. And then there's ways that you can set up these tools within your workflow, so you never have to worry about doing the correct number of spaces and indentations. And the way that's commonly recommended to do it is actually to integrate it into your Git workflow. So I guess you remember these Git commit messages we did. So whenever you do a Git commit message, essentially it's going to run a script to kind of reformat your code. And then if it had to change your code, it's going to ask you to re-add or restage the files that it's changed. So the way you would install it is through what are called these Git prehooks. So these would be like the boilerplate commands you would run. So within your virtual environment, you would install these packages, and then you also need to just create these 3 files, which kind of define your configuration for formatting. And then the first time you commit, it may look like something like this, where it reformatted these files. So then we need to add those files again. But there may be some files that it couldn't figure out how to properly reformat it. So then those you'll have to manually change yourself. And it's going to essentially, what's nice or what's not nice about it is that it's going to not let you commit until you satisfy the formatting rules. But then that helps you have a cleaner commit history. You don't have these commits that say reformatting, because if these things will force you to reformat. And then you just have to re-add those files. So this is through the terminal, but you would see a similar thing on VS Code where it says, I have an error outputs. I wasn't able to commit. So when it's passed, it'll say passed. So that's the first thing. Before you do packaging, is good to format. And then packaging, essentially, you'll have a structure. There's 2 schools for packaging. Usually you'll have like this folder within like your repo, which will have all your source code. And then you'll have this _init file, which can be empty. Don't ask me why, it's just how Python discovers files internally. And so one school of thought is you have this setup file. The other is you have this setup.cfg. So I guess you'll see it here or maybe the next one. But then the main things to define are where the README is. So that will be kind of like the info about the package. The syntax you use for the README. So we talked about Markdown, or there's this RST dependencies, so that when someone pip installs it, it will actually automatically install those dependencies. And then you can test it locally actually by just doing pip install -e dot. And then in this case, you can see that I can import my source code as if it was a package, as I did import numpy as np. Here I do import pydevtips, which was the name of the folder I created here. All right. And this is the last slide on how can you then, here we were just able to install it locally. Now to make other people to be able to run pip install pydevtips or pip install blinerot, whatever, I don't know. So you need to make an account on PyPy, which is, and I guess you can do the same thing with Conda, where this is like the registry of all the different Python packages. And then they have a Python package for pushing Python packages called twine. So you have to install that. And then you run these commands. So pip install twine, you build your package, and then you upload it. Those are the 3 steps essentially. And yeah, you can make as many Python packages as you want. There's no one's checking or charging you or for pushing Python packages. But yeah. So once if you ever into or interested in publishing a package, that would be the process essentially. And yeah, that's it for pydevtips. Just 1 minute over time. If you have any questions, let me know. Yeah. On Zoom, anything?
Zoom now.
Okay. All right. So hopefully, yeah, that helps you for your projects. I guess you'll see some more tools like WandDB, and as you dig deeper into PyTorch, and also I think Peter will show a template specifically for deep learning projects, which will use Hydra and maybe try to follow similar code structure ideas. So yeah, hopefully that's useful for this, but also for your other engineering projects. Yeah.